Good morning. My name is Megan Cruz, and thank you so much for spending part of your weekend with us to watch PACE's NASA Social Panel. PACE is a NASA mission targeted to launch on Tuesday, February 6th at 1:33 a.m. Eastern Time from Space Launch Complex 40 on Cape Canaveral Space Force Station. It'll be NASA's newest Earth-observing satellite to help monitor our planet and its changing climate. Now, today's audience is a group of digital content creators visiting NASA's Kennedy Space Center for a NASA Social. They're going to get a behind-the-scenes tour and are now getting a unique opportunity to chat with some of PACE's experts. So to my left, I'll introduce them now. We have Karen St. Germain. She's the Earth Science Division Director with NASA. Marjorie Haskell, PACE Program Executive. Laura Lorenzoni, PACE Program Scientist. We also have Julie Lander, PACE Deputy Project Manager, and Ivana Satanich, PACE Ocean Scientist. Did I get that right, Ivana? All right, so they'll be taking questions live from the audience here in the room as well as online. All you have to do is use the hashtag AskNASA. But first, a little more from each person, so we'll start again with Karen. So Karen, tell us about NASA's Earth Science Division.
Well, good morning. It's great to be here with all of you. And many people don't know it, but NASA has over 24 instruments, missions on orbit looking down at the Earth system, observing different parts of the Earth system and how those are changing. By that I mean how water moves around the planet, how carbon moves around the planet. And these systems can have a profound impact on how we live our lives here on Earth. So PACE observations will contribute critical new information about ocean biology and also the interactions between the ocean and the atmosphere, particularly around aerosols. So we'll accelerate our understanding of how aerosols impact our climate and also increase our understanding of ocean biology as it relates to the fisheries and coastal communities as well, informing a lot of people who are looking for science to inform the decisions they make every day.
Perfect. Thanks. Yeah, really great science that's going to be conducted with this mission. And Marjorie, I like to think of you as like the liaison of the PACE mission, right?
That's right. So I'm the link between the project and NASA headquarters. So my job is to keep my management in the Earth Science Division and the Science Mission Directorate informed about the status of PACE, and that includes cost, schedule, any technical issues, and then any programmatic concerns that we have, and advise them on decisions regarding the project. And then the other side of my job is actually to help advocate for the project. So I work with the project and make sure that headquarters is fully understanding the status of the project and any issues that they may be encountering in areas that they may need assistance or they just may need headquarters to be aware of.
So it's like you're making sure things stay on track, essentially.
That's right, yes.
All right, so Laura, PACE fits into a larger ocean science portfolio within NASA, right?
That is correct. And as Karen very eloquently put it, NASA is really invested in Earth observations, and we wouldn't be able to understand climate trends unless we had those sustained observations of our planet. And PACE joins forces with more than 25 years of continuous ocean observations, which are really critical for us to understand and untangle our anthropogenic or our human input and influence on climate versus what is just a natural oscillation. And we've just had last year another launch with SWOT. And so PACE and SWOT really are the two newest jewels of our wonderful Earth observing fleet. And they're going to help us understand water on land and obviously the ocean in ways that we haven't before.
Great. So Julie, you make all this science that we're talking about, you make that possible by bringing together the hardware, right?
Yes, yes. So we take the dreams and visions, you could say, of the scientists and the engineers and technicians we have at Goddard Space Flight Center. We put it all together and try to come up with the best way to test it. So this project started in late 2014, and there were concept reviews, and it went through several iterations even to get the primary science instrument designed in a way that will make the dreams of the scientists happen. And so we're very excited. We've got, 3 great instruments. We have some from the Netherlands, one from UMBC, Baltimore, and the rest, everything was built, most of it in-house at Goddard with over 500 different engineers and technicians, and it's very exciting. We're all excited. We're so close to being here after all the hard work, blood, sweat, and tears of the team.
Yeah, from 2014 for sure.
Yeah.
All right, Ivana, so you're on PACE's science team. You focus specifically on ocean life.
Yes, so I'm part of the in-house group of scientists that has been working with everybody else who spoke here before to actually, inform the engineering to be able to build what we've been dreaming for like 20 years. As Laura said previously, we have 25 years of observation of Earth and ocean, but we are limited with what we can see. So our dreams of seeing ocean in hyperspectral way are coming through thanks to the hard work of everybody who spoke before and everybody who works under them. So I'm really, really excited because this is going to allow me to do the science that I'm interested in so much better.
Yeah, I'm hearing the word excited a lot, and yes, there's a lot that's we're gonna be able to accomplish with PACE, so it is very exciting. Okay, so now is the time for us to invite those here in the room to ask questions. All you have to do is raise your hand, and then you'll have one of these two lovely ladies bring a mic over to you, so just wait for that. And then also, if you're watching online, you can submit a question using the hashtag AskNASA wherever you're watching this briefing. So anybody here in the room, don't be shy, you got up early. Right here.
Tomorrow, and we're all hoping that everything will go beautifully. After the satellite has deployed and it's reached its destination, how soon will we start seeing data come back?
Go ahead. We will launch, and then we deploy our solar array, and then we will be able to get data starting at about 29 minutes after launch. But it'll take quite some time, like a couple of weeks before the instruments kind of get turned on and everything else. So we won't have first images until probably mid-March. So, but yeah, we're looking forward to that first half hour of getting data for sure.
Yeah, within 29 minutes.
Can I add something else?
Of course.
So it just something very important is all NASA data are open and available. NASA has a very strong open science policy, and anything that we produce, it's for you, it's for the public. And so all the PACE data are going to be available in the PACE website. As Julie mentioned, about mid-March is when we're expecting first light. And please go ahead and use those data. It's going to be a treasure trove of fun stuff to look at.
Perfect. Over here, yes.
Yeah, hey, great work, y'all. I'm from an astronomy perspective. We're interested in clouds. Obviously, that kind of puts a bad thing on what we do. Will y'all's data kind of help modeling? Because we use several models to make sure the sky is going to be clear, and a lot of them are wrong a lot of the time. And so I'm hoping that maybe some of y'all's data will be forwarding that.
I can take it, definitely. So yes, that's exactly what we're excited about. Having polarimeters on PACE, that's going to allow us to see better, understand better the formation of the clouds. Where are they coming from, where are they going? Because PACE is going to be looking in that interaction of the aerosols and water and the atmosphere, it allows us to understand better the formation of the clouds. It's actually one of the biggest uncertainties in our understanding of the climate. I think Laura mentioned before, is just really that interaction of aerosols and clouds and water. So having those additional polarimeters, they're going to be feeding at those kind of modeling. So yes, hopefully, we're hoping that be able to like actually forward the data, not just for like, the science, climate science, but also the weather science as well.
That was a great question. Thank you. First row over here.
Hey guys, so I've been hearing a lot about we're going from like an 8-color crayon set to like an 120-color crayon set. And so I'd just love for you guys to just give me a little bit more insight into what you really mean by that. For like a layperson like me, like what does this mean in a data perspective?
Unless anyone else wants to take it.
Yeah.
Go ahead.
Okay, so I think in simple terms, like if you think of like all the great pictures Hubble had and everything else, and the James Webb Space Telescope is just blowing it out of the water, right? So that's where we think we're going to be compared with the MODIS instruments, and those were like more simple. And the technology we have on board with between all our 3 instruments are just going to be, it's going to be outstanding. And so we'll be able to see shades of red and shades of blue, and that's going to help the scientists, determine what's good and what's bad. And I don't know if you guys have other science.
And do you want to go ahead?
I just want to add, so, I see you have cameras, and a bunch of us have cameras. So, when you're like, you're content creator, you tinker with those photos, so you open up that image, and it has those 3 little bumps, RGB. So we're going to have 250 of those bumps. So just think about the information. I think that's the best way of seeing it. We're going to be able to resolve really, really high spectral resolution, and that's amazing because there's information hidden in each of those bumps. You know that really well now. So that's your comparison.
I actually love that we use that analogy because when you said it, everybody's eyes in the room went, oh, wow, yeah, that's a lot.
All of us put some filters on our images, don't we? So, yeah.
Keeping it real over here, Amon, okay. So let's go to an Ask NASA question. So this is from Darium H on X. Where will the scientific community be able to find the PACE data? You mentioned that it's available to the public, Laura, so where can they find that?
It's all going to be on the PACE website. And I don't know it by heart.
So yeah, all NASA Earth data are available through Earth Data Portal. So PACE will be there, but pretty much if you go on our website, there's going to be a place where it's going to link you to Earth data. All our data that is collected on the ocean side goes through different DACs. These are different data distribution systems, but everything is coming ultimately through Earth system data. But our data is going to be fed in different, like through our application people, through our partners, to different models. You're probably going to be finding it at NOAA and other places, but pretty much Earth system data, Earth data, that's where you're going to find PACE data for sure.
Okay, this is another one on social. So which oceans will PACE study?
All of them. And I say that because one of the great things about viewing the Earth from space, and particularly low Earth orbit, is we can get a global view. PACE will pass over all of the Earth's oceans, and we'll be able to see not just the U.S. coastlines, which are an area where our own communities are very, very interested in the data, but we'll be able to see the entire globe.
Great. Any other questions here in the room? Go ahead.
So once PACE is done collecting the data, it's done its mission, what happens to the actual machine, and what happens to it? Does it get reused, or it?
Oh, you want to talk about? So you mean at the end of life?
Yeah, at the end of the life of the mission, what happens?
Right. So PACE was designed for a minimum of 3-year mission life. That's the minimum we expect. We carry consumables, which means fuel to maintain station keeping on orbit for 10 years at least. Many of our satellites live a very long time. We have some on orbit that have lasted over 2 decades. So we are all hoping for a very long life for PACE on orbit. And then when it's time to decommission our satellites, we have a process for doing that. Do you want to talk about that?
Yeah, so we have to design all the parts so that they're small enough upon re-entry into the Earth's atmosphere that it kind of disintegrates, you could say, so nothing falls back. So we have a whole series of maneuvers, and we have to keep enough fuel that helps us make sure we can do that and re-enter the Earth's atmosphere, without causing any harm. So it's a very complicated analysis that's done, but
So
yeah.
it basically comes down.
Yeah,
and
it comes
burns
down, but
up.
you won't see it.
But you can't reuse it.
But you won't see
Yeah,
it.
it's not, it is recyclable maybe, but it's not reusable.
There was another question on this side here. Right over here. Thank you.
Thank you. Who will this mission benefit? So how will it impact people and society? Thank you.
You want to?
Okay, I'll take that one. Okay. So PACE will actually benefit everybody. It will benefit all citizens of the world. The data from PACE is actually going to encompass the entire globe. So we will have data for everybody, and as Laura mentioned, it's open access. So everyone will be able to pull that data from your average citizen all the way up to research institutions to help better their information.
I was going to add too, when I started on this project, my sisters were asking me, because that's right when the manatee around Florida, there was no seagrass for them to eat and they were dying, and they were like, is this project going to help save the manatees? Because I really hope so. So I think so, yes.
So maybe we could add a couple of words about how the data benefits society. So we're looking at these phytoplankton, these very, very small, the phytoplankton are at the base of the marine food chain. So better understanding what types and where these phytoplankton are through the very high fidelity observations from the ocean color instrument will help us understand sometimes those phytoplankton are toxic, so we'll want to be able to warn people about that. They can poison fish, but they can also make the air unbreathable, so that's important for recreation and for the fisheries. So that's one way that PACE will directly benefit communities around the world. I don't know if you wanted to add any other ways.
Well, one of the things, as PACE's name indicates, is plankton, which Karen mentioned, aerosol and clouds, which impact or give us information on cloud formation, aerosol movement, which is one of the biggest uncertainties we have when we try to understand how fast our planet is warming. That radiative heating is one of the places where we don't understand enough. So PACE is going to help us with that. So it's going to help us better understand and put constraints to our climate model so that we know where we're going in 10 years or 20 years. But PACE is not in its name, but PACE, as Karen mentioned, it is a global mission. So it's going to be looking at land too. So there are a lot of land applications like agriculture, like changes, land use and land change that PACE is going to be able to help us see.
Great. I think we have a question. Somebody in the room wants to ask Ivana a question in Spanish.
Go, Ivona.
Oh, I speak Italian, so I'll add S in the end. I think the question in Spanish should be towards Laura.
Oh, for Laura. Okay, sorry about that.
Okay. We'll let Ivona wing it. I'm curious to
I
hear.
specifically asked. I said, "Does Ivana speak Spanish?"
Italian.
The question over here.
I wouldn't want to take a space from the from the content creators if they prefer to do it
I think there was
themselves.
a question up here.
Okay.
Sure, over here. Oh, give us 1 second. Let's just get the mic to you. Sorry about that. Okay, go ahead.
I wanted to ask, does NASA plan to partner with any other countries like space organizations, or are you guys spearheading it alone and then sharing it with them? How is that kind of working, since it's like a global initiative?
So I'll speak broadly, and then we can talk about the specific partnerships on PACE. So NASA partners, we have agreements with more than a dozen countries more than 100 countries around the world. Some of those are about building missions together, and we do have an international component to this one. We have international components to many of our missions, and then with many, many countries that don't necessarily build flight hardware, we have partnerships on how we use the data to make sure that it's, again, benefiting citizens of the world. And do you want to talk about the partnership on PACE specifically?
Yeah, so we have one of our polarimeters, which is one of the instruments that kind of, if you think of your polarizing sunglasses, how you can see different things. So we have two instruments that'll complement the ocean color instrument. And a group from the Netherlands, led by Esron and Airbus, they said, hey, we want to be part of this great mission. And so they became partners with us, and they actually delivered their polarimeter on time. They've been supporting all our tests. They're flying back and forth from Amsterdam. So yeah, it's been a great partnership. And yeah, and the data will all be available, like we said, to everybody around the world. Yeah.
Can I just jump in one more thing? So one thing that PACE mission has been doing for a very long time, it has this really strong applications program, where they worked really hard over the last couple of years to open and prepare everybody in the world to accept this data. So through that program, they had these yearly meetings. We had up to 1,000 people from all over the world joining in, learning early how to use this data. So once it's launched, it's available to everybody out there. So no, there's just kind of like we tell you, go to this website. They know how to go to this website. They know how to use it. We've been working with them so they're ready and start taking it for their usage all around the world.
I'd like to go to social again really quick. So on Facebook, oh, sorry, did somebody? Oh, just go ahead. Oh, two.
Sorry, and then I just wanted to ask, so as digital creators being here trying to learn about this and educate our followers, this might be a tough question because it's such a complex mission, but what's the most important thing that you guys think we can share? And is there anything that they can do on their own? Because I know when people talk about climate change, they talk about how we can do things kind of on a micro or a macro level. Are there things that you would encourage us to tell our followers to do or keep up with in order to help this mission succeed?
That's a great question. I think, can we go around the table?
Sure,
Because I think you're going to get 5 different answers.
Karen, do you want to start?
Yeah, so whenever folks ask me what they can do, my first answer is get involved, right? Because the changing climate, the changing Earth system has different impacts in different communities around the world. So I always ask people to get involved with the issues where they live and make their voices heard.
I would just say that I think that everybody has a different passion that they're interested in, especially when it comes to the planet and saving the environment and our Earth. So I think if your passion is ocean conservation, then you should focus on that. If your passion is air quality, that should be your focus. So I think you should tailor what you do to what your interest is and what you can do in the neighborhood that you live in. So somebody in middle America that's surrounded by land, they're not going to be able to do much for the oceans necessarily, but someone that lives on the coast, they can definitely get involved and save the manatees, like Julie said. So that would be my advice.
I would say even one single person can make a huge difference. Because it's just you, don't think that you can't make a difference. So definitely be active. And one of the things that we love about PACE and about working at NASA is how much it inspires our younger generation. So definitely if PACE is a keystone of inspiration, I think we've done our job, because we would want every single kid around the world to follow their dreams, and that is how you actually make change.
Yes, and I agree with everybody, everything everybody's saying, that, yeah, you just find something you're passionate about and you can find ways to get involved. And it could be you decide you want to follow engineering and you want to help build these things, because we're always going to be looking like the Earth's just getting more and more complicated, and so, maybe you want to be an engineer or technician or to learn to do something you've never done before that could ultimately benefit everybody. So, yeah, it just take a challenge, do something fun.
I mean, everything what they said, but it's like I'm trying to find something inspirational in you. But I think, kind of rolling back, your question was more kind of like how would PACE help with that? And what excites me about PACE is that I think it's going to be such a beautiful platform, because each of us has our own interests, and because it has so much information, is going to be able to give all these little specific answers. And is it manatees? Is it air quality? Is it harmful algal blooms and stuff? And we work really hard to make it available for everyone. So that's where my passion is, I think, trying to give everybody here tools so you can actually be, work on your question that you're passionate about. That's kind of where my passion lies, where my excitement lies about PACE and everything.
Do you mind if I actually go back to social really quick? Sorry about that. So a lot of actually users on Facebook are noting that this panel is all women. So if we could go down the line, they're really interested in hearing how you got started in your career to where you are now. Ivana, your face. You have time to think. No.
Do you actually want to start with your one and go all the way down this time?
Yeah. It's me first?
Yes, now
Well,
it's you first.
I didn't say that. They did.
Okay. I mean, I come from coastal Croatia. It's a small country in Mediterranean and Adriatic Sea. My whole ancestry always depended on the ocean, lived by the ocean. When I was a kid, I literally was my grandfather's boat, and it's like, if the seas are red, the weather's going to be good today, and stuff like that. And kind of I understand that dependence. And then life took me into biology, then it took me into oceanography. Then I saw, I really like flashing lights, and, doing ocean optics, and ocean color has lots of flashing lights. So there's a love to disco and love to ocean brought me to where I am right now. I'm just very passionate about what I do, and I'm happy it's recognized. So I'm happy to work here with this amazing team.
Yeah, and I, being good at math and science as a female in the 80s, so I was looking at different engineering and mechanical. I just kept thinking those were car mechanics, and electrical I wasn't sure about. But I always thought, hey, I came to the Kennedy Center when I was a kid, and I thought that was really cool. So I thought aerospace engineering would be really awesome. So went to University of Colorado and did aerospace engineering. There were only about 7 females in our graduating class of aerospace, and put resumes out, and I got a job at Goddard Space Flight Center, and I've been helping build and develop instruments, so I really appreciate the science, and I've always worked with the scientists on every mission I've done, which is about 10, and yeah, I just kind of made my way up through engineering, and now I'm in management. But having done the basis of all the engineering, you really understand it, which I think helps us, my counterparts with management and everything, that we understand how the instruments need to work and what is the goal, and on orbit, what we want to get with the science community. So I'm very excited, and I love my job. It's great.
And we do have gentlemen that work in PACE. They're very dashing, they're very nice, and we love to work with our male colleagues. We do have PACE is a very diverse team, which we're very proud of, and not just gender-wise, but also from different parts of the world. So we're always excited to highlight that. So I was born and raised in Venezuela, and obviously Venezuela does not have an aerospace program. I always wanted to be an astronaut, which obviously didn't work out. But and this is why I always love when we talk to kids, and especially little girls, it's always about chasing your dream. I never gave up on just that space, just working in space. And the reason I ended up working in the ocean is because we know more about the surface of the moon than we do about our deep ocean. And it's because it's challenging, and that's what makes it exciting. And that's why I pursued marine sciences, because I did want to learn about those mysteries of the ocean, which are just as exciting as learning about outer space.
So I actually grew up in a small town in Michigan, and I was the kid that was always asking how things worked, why they worked. And growing up, I actually wanted to be a teacher. I got to high school, and my science teacher suggested I look at engineering as a career path because I had an aptitude for the sciences and for math. And so I talked to my parents, and they put me through a summer seminar on what engineering is in the different areas, and I decided I was going to be a chemical engineer and changed my career path at that point, and was lucky enough to get an internship at NASA Goddard. And so I started there as a co-op when I was in college, was hired after I graduated, and I've actually been working for NASA for 24 years now. So I spent 20 years at Goddard. I'm working on the flight project side, so back where Julie is now, and 3 years ago, moved over to headquarters, and so now I'm on the management administration side. So,
I'll actually briefly start much earlier because we've talked about the importance of speaking to students. When I was in 8th grade, I struggled with algebra, and the teachers told my parents I just didn't have a math mind. My parents I was very lucky. I had parents who persisted, and they sent me to summer school, where I had a teacher who figured out immediately what concepts I was missing, and that experience unlocked gave me the keys to the career I ended up having. I graduated at the top of my high school class with a strength in math. So, you know, there are these important pivotal moments where, you know, when we support our kids, it can really open up careers. I then went into engineering through the instrument side. I built instruments that make these kinds of measurements. My first science experience was flying through hurricanes. And that is the experience that made me a scientist for life, because the science was fascinating, but it was an experience that taught me how important science is in saving lives around the world. And a number of jobs later, I ended up here running Earth Science for NASA. It is the job of a lifetime, an incredible honor. And I'll say one more thing about diversity at NASA. One of the things that is most inspirational to me about NASA is it's not just what we do, it's how we do it. And NASA really values diversity because we know how important that is. I was just about to bust a move. We know how important that is for getting great outcomes. Science, the quality of the science we do is driven by the quality of the questions we ask, and different people ask different questions. And so we're really proud of the diversity, and as Laura said, we have a very, very diverse team on PACE and in Earth Science in general.
Thank you so much. That was a really great question from Facebook, and thank you so much for sharing your stories. I know there's more questions here in the room, but we actually have to wrap up. I'm so sorry. You guys have a really busy day, so we want to get you out of here so that you can start your tour of Kennedy Space Center. Now, if you are watching and you're a digital content creator and you're interested in joining the next NASA Social, just want to let you know you can look out for future opportunities on nasa.gov/social. And then meanwhile, you can join in on the PACE conversation leading up to Tuesday's launch by using the hashtag #KeepingPace. Okay, again, a huge thank you to all the panelists here and everyone who joined in person and online. Again, a reminder that the launch coverage of PACE will begin at 12:45 a.m. Eastern Time for a launch this Tuesday on the 6th. We hope you can join us.